Greetings, this is Wertak again. I wanted to show some examples of some of the work I've been doing lately. This is a slab here of some Danish flint that I purchased from Greg Nunn, and overall I'm really pleased with the material, but I have noticed some differences from the typical flints that I use from Texas, and so I have a few examples right here. These pieces of Texas flint, typically I have to bake around 575 Fahrenheit in order to get them to work a little bit better, and they produce a nice shine and they flake really well. Well, I tried the same thing with this material, this Danish flint, and it's got a nice luster to it, but I noticed that at the higher temperatures it tends to be a little bit more friable. It's got some cracks running through it, and you know, the luster's great. I mean, it's really shiny, but it's just cracking in these directions that just means I overdid it. So what I found out, and you know, I didn't ruin too much rock by baking it too high, is that instead of a heating temperature as high as I would normally do with the Texas, I found that if I lower the temperature closer to 320 Fahrenheit or 160 degrees centigrade, that this Danish flint works a little bit better. Now, as you can see, I had, you know, some pretty big slabs cut up, and you know, when you get material that's this rare, you kind of want to slab it simply because of the cost associated with it. But you can see that actually, you know, I've made quite a few pieces. Most of these actually I didn't even bother baking. That's what I've found, and it's very interesting. I mean, the flint itself will actually work really well, at least for me, but it's kind of a new challenge for me, and so I've been trying to make larger and larger pieces, and I've run into some simple issues that I wanted to really kind of talk about. But before I do that, I just want to show the tools that I've been using. If the slabs are really thick, and I'm talking closer to an order of an inch, and I had some heels cut, I discovered that actually some of these sandstone hammerstones work really great to clearing the slab so that you remove any cut marks. And then after that, I've been using these tools. Now, I've shown these tools before. They're kind of these flat finishing boppers, but I purchased some boppers. These are solid copper boppers right here from, I believe it's Flintknappingtools.com, and they're great. And actually, I wanted to find out a little bit more about it, and this is what's the cool thing about being a scientist and having access to equipment, is that I wanted to see exactly how that solid copper was incorporated into the Delrin. And if you look right here, this is a picture of an x-ray. It's a press fit. You get a lot of copper for the tool, so this is not going to come apart on you. So it's a well-made tool, and I would highly recommend anybody who's interested in solid copper boppers to look into it. And then I have I use my Delrin handle pressure flaker just to kind of clean up platforms and get them prepped for more percussion strikes. As you can see, this is very similar to some of the other tools I've got. It's got a brass insert here with an Allen screw to hold down the copper tip there. I love these tools. These are great. And this was a handle that was made by a buddy of mine, Matt, and you know, his design was mimicking those for wood lathes, the type of tools that you use for turning wood. And so that's the inspiration of the shape of the handle, but these things are great. So anyway, so that's kind of the background. So down to the problems that I faced, and I can actually show an example. Being inspired, I decided to try make something bigger here. This is a piece of obsidian, and overall I kind of like it, except for some minor little things that you know, came about, and I'm not too sure how well this is going to show up. But what happened was, you know, I get about 2 inches into the piece here, and then it would hinge out, and so it looks ugly right here in the middle. And you know, maybe I'm being too critical, but on the other hand, it's kind of important to learn by your mistakes. And so I'd only get so far, and it would hinge out, and then, you know, just to get rid of the cut marks from the saw, I would you know, try to push off material from this direction, and I don't know, it's a very unsatisfying finish to the material. And I may thin it up or narrow it up a little bit more, redo the platforms and try to remove this material. But what it does show is what your limitations are in terms of percussion, and I find that my limitation is just the size of my hand. How do I hold it? And when you're trying to percussion something and you can't support it properly, you get into trouble. And when I put it on my leg, when you try to swing that billet, hitting your leg, it just feels really unnatural to me, and I just don't like it. And you know, these are just personal observations. And so when you put it on your leg like this, and you swing and you're hitting your leg, and it just feels like you're holding back because you don't want to smash your leg with a bopper. And so what I found is that changing the way you hold it a little bit, like supporting it like this, having some fingers in the back like this when you hit it, actually can help a bit, because you need that back pressure when you hit. And so it's kind of an idea that's developing. I know that there are a lot better knappers out there, and they've figured this thing out. I mean, they don't mind hitting on the side of the leg and can get good results, whereas I'm still just trying to work out some of the details of trying to make a flake go a little farther. So I just wanted to show kind of an example of a guy who's sort of in the process of trying to figure out making larger dance blades, for example. So I find that my issue is, how do you support it? And that's the back support when you actually strike it. And so there seems to be, for me at least this point, a limitation. And so this is not quite 4 inches wide. It's a bit shy of it, but I find that seems to be my limitation at this point. And it has everything to do with me attempting to support the piece. So if I normally support it like this, it's very difficult. And without having some direct support near the edge, because my fingers just don't reach, you tend to snap off big pieces. You can have like a C material, like a C that breaks right off because you didn't support it at that point. And so instead, I've been trying some different techniques as far as how do you support the thing. And like I say, if you know, if necessary, you twist it around and do what you can in order to get that support. But if I hold it like this, for example, I feel a little bit better, and I can swing, miss my leg, and actually get some decent flakes off. But it's a work in progress, and this sort of surface texture is just really unsatisfying. But I view this more as a learning process, and it's kind of important to understand how you support it, and it's that back pressure. You're going to hit it, you need something to push back, like the back of your hand, your leg, or whatever. Lots of people have different techniques. It's what I'm discovering is my limitation in terms of how far I can throw a flake. So that's with this chunk of obsidian. Here's a piece of the Danish flint, and as you can see, it fits my hand a little bit better. I haven't had any real issues with it, and this is not baked, and I've been, you know, really, you know, gotten quite far with the materials I have, and in particular these solid boppers here, these ones that I purchased, these have been great. But I still really like my these boppers here with the flat edge, just for finishing. You can really throw a flake, and so I just wanted to kind of show what I've been up to and the type of points that I've been making, just to kind of give you a feel for just the progress that, you know, that I'm making on this, and how just because you're used to baking flint doesn't necessarily mean that you've got all the answers. This Danish flint, lower temperatures, 320 Fahrenheit. That's about the max for this. So I just wanted to show this. Oh, and here's a point. This is about a 9-to-1 ratio, and I think it's kind of funny because, you know, it's cheating. I mean, really, you know, make a triangular piece. The width's pretty good here. You know, it's that's a little ridiculous. So you can make a width the thickness ratio to work with you if you just, you know, mess with the geometry. I think a triangular shape like this is a bit of a cheat. Anyway, so that's about it. I guess we'll talk to you later. Bye.